Well, so we got charge. Can charge change? Well, yeah, it can change. You imagine an electrical wire. Okay, you got electricity going down the wire. That means you got electrical charges going down the wire. So charge can change. That means you're getting less charge in one place, more charge in another place. And so charges can change. So we define electrical current. So we want to talk about electrical current. The symbol we use for electrical current is I. We don't want to use C for current because we use C for speed of light and constant and several other things. The electrical current, I equals dq dt, the rate of change of charge. Average current is going to be the total change over time. Okay, so again, this is very much, again, kind of like when you talked about velocity and average velocity in chapter 2 of physics 1. Same concept. Okay, and again, my philosophy here is let me keep referring back to physics 1 while we're doing physics 2, because if you've got physics 1 down solid, then that means you've got physics 2 also. It's just, you're just changing the symbols a little bit, but the basic concepts are the same. Okay, so basic unit of electrical current is going to be, so if I is dq dt, that's going to be a coulomb per second. A coulomb per second we call an ampere. Symbol for ampere is A. So that means an ampere is a coulomb per second. Now, we often abbreviate ampere because that's just hard to say, so we often abbreviate it as an amp. Okay, but really we ought to call it ampere because that's actually the guy's name, and we want to give credit where credit's due, and actually Andre Ampere, and figure out, that we need to do to give him credit for his work in all this. But anyway, an ampere is a coulomb per second. Now, this is where things get a little bit interesting. Okay, so a footnote to this whole idea of amperes. The SI unit for electrical charge is the coulomb. SI unit for electrical current is an ampere. So an ampere is defined to be a coulomb per second. Okay, now here's the really interesting thing, and that is that when they define units, actually measuring charge is tough. It turns out it's easier to measure a change in charge than it is to measure charge. And so what they have done is the actual standard, international standard, is that a coulomb is the amount of charge that you get if you have 1 ampere for 1 second. So 1 ampere times 1 second is going to equal 1 coulomb. Okay, and so we actually define the ampere as the SI unit of current, and the coulomb is derived from the ampere. I know ampere is a coulomb per second, but a coulomb is the ampere is actually the defined thing. Okay, and for a long time, they figured out that what they did was they had a definition of an ampere as the amount of current that goes through a particular sort of thing, with a certain voltage and a certain amount of time. Now what they do is in May of 2019, internationally they redefined units, and they made an absolute definition of the fundamental charge. The fundamental charge is 1.602 1766 34 times 10 to the minus 19 coulombs. That's defined. It's not measured. They now define that. Okay. And the ampere okay, is defined here by looking at, for example, in a when a transition of an electron in a cesium atom gives off energy that is defined to be 91926317770 hertz. Okay, and so what they do is they now define an ampere in terms of these fundamental things that were also defined. So the ampere is actually defined. And so now we define the ampere, and from that we figure out what a coulomb is. So that's just kind of a footnote as to how units work. In case anyone's interested, most of y'all, that is not going to be a major deal. Some of you that are going into the more technical aspects of electrical engineering, you might want to look up a little bit further about the new definition and the new definition of electric current, the new definition of the fundamental constants and so forth. That was put into place in May of 2019. So if you're interested.